Here we are. This is the second class meeting, so we talked about the first two chapters the first day, and now there's a quiz that you should do today, although the asterisk means you have a few weeks before you lose any points for being late, but you should do the quiz on a topic before that day discussing it. And I put 1 to 2 this way and 3 this day. We're going to do part of chapter 3 today and part of chapter 3 tomorrow, and this is basic web technology. And you should start doing hands-on projects. ED 102, I think I demonstrated last time. But I'll demonstrate W600 and ED 103 today. The demonstrations are a bit ahead, and that's good, so you can start doing the hands-on projects. And as a student pointed out to me, there's an H110A project in Canvas. That should be removed because you can't do it. That's Linux Journey, which I would like to have you do, but the website is down, so just ignore that project for the time being. It's a great project, but you cannot do it until they bring that website back. So I wrote this other one, W101, to replace it. And I guess we did not get the other one removed from Canvas, which we should have. Anyway, so let's start with basic information about the web. Web application technologies, this whole class is about hacking into web applications, and therefore you have to understand how the web works. So, HTTP is the basic protocol. This was designed to make the internet, and it was designed for Web 1. And Web 1, the original web, was just like broadcast television. You would have a static page that just had text and images on it, and you'd have a lot of people viewing the page, and they'd all be viewing the same page, just like people could tune to a television program and they're all just viewing the same program. It was not an interactive activity. You were all just viewing the same thing. And that's what HTTP was designed for. That's what it means by being connectionless. It does not know who the viewer is. You make one request, you get one reply, and when you come back and make a second request, it has forgotten everything about you. It does not maintain a session or know who you are or know anything about logging in or anything like that. HTTP is just a delivery protocol where you ask for a page and you see the page. So you send a request, you get a response, that's it. This is called stateless. It doesn't remember anything. And the point of this is it is cheaper and faster for the server. The server does not have to have a memory. It does not have to have a database keeping track of which people have logged in. It just takes requests, answers them, and then it's all done. Now it takes the next request, it can answer it, and clear its memory out. That was the plan. So an HTTP request is just a plain text request. It looks like this. You have GET, the name of the page, and then a version of HTTP, which is usually 1.1. Then you have the name of the host, and those two lines are all you really need. You can just press enter twice at the end of that, and that is a sufficient HTTP GET request. In fact, I should be able to do one of them here. Let me bring up my command line. I should be able to do it here. If I do netcat to one of my servers, ad.samsclass.info on port 80, that'll open this. Now I can send a GET. The root page, http:/1.1, enter, enter. And that's a bad request because I didn't include the host. But it did understand I was trying to make a request. Now you got a response code of 400 for a bad request, telling me something's wrong and here's an error code. Yes?
Bad request.
This is a bad request.
Bad request is bad request.
Yeah, bad request means that the server could not understand what you asked for.
Oh.
So it tells me it did reach an HTTP server, but it wasn't able to do what I asked for because I formed it incorrectly. And so this is the response. You get a header from the server with a bunch of information about the server, and then you get a web page. But this web page is just an error message telling me it was a bad request. Now let's try a good request. If I do that again, I connect to my server and I do get/http:/1.1. Now I put in the host line, which is required by HTTP 1.1. Enter, enter. That's a good request. And so I get a big page here, and there it is. So now I get, this is a properly formed request. The GET, the host, and then a blank line terminates it. And now it tells me the status is 200 OK. 200 OK means it understood your request, and here's what you asked for. 400 means it didn't understand you. And so then it responds with some header information about the server with things like the version of the server and the date. And then it responds with the contents of the page, which is an HTML page here. And all right, so that's how the simplest kind of web request works. Now, a real web request normally these days has a whole bunch of extra fields here. And if you make it from a browser, including things like a user agent that tell it what version of the browser you're using, and cookies. and other headers like referrer, which tell it where you came from. And this tells it that I will accept zipped pages from the server. If your server wants to send you a page all full of text or big images, it might want to zip them just to save bandwidth. And if your browser will accept that, it will send this saying you can zip the content, and just to make it smaller for faster transmission. And you can also tell it what language you'll accept. So that's the start. So the first thing you see is the verb get. Get is also called the method. The most common method is get. Get will just get a page. Post will send data up to the page, like username and password, and there are other verbs, but the most common verbs are get and post. Then you have the URL of the page. In my case, I just use / for the default root page. Here it's got some longer CSS page it's getting. And this, by the way, is the query string. If you go to a web page like google.com, you can then do a search for, say, dog. And now you see up here in the URL, google.com/search, then a question mark. And what comes after the question mark is a query string. And you see it's Q equals dog, and then other information. So that's called the query string. The google.com part tells it what server you're talking to. Then this tells it a folder name and perhaps a file name of which particular document on that server you're talking to. And the query string includes data that you send to that document, which would be a script. So I'm reaching some kind of script on the server that can process a request, and I'm feeding data to it, which is a query. Now, data put up here in the URL is called the query string, and this is considered not confidential because all the data is usually encrypted. If the URL starts with HTTPS, this is the schema, the first thing you see, HTTP or HTTPS. If it's HTTPS, that means all the data is encrypted and includes all the data in the query string. But the query string is handled in an insecure way. If you save a browser shortcut in your bookmarks bar, it saves the query string. The server log at the server will save the query string. So it is bad form to put anything private in the query string, like a password. You can write a page that passes passwords up here, but is considered unsafe. All right. And so anyway, that's the start of this. You have a version of HTTP. There is something called HTTP2, which Google has been pushing, but it's not in common use yet. Most everything is still using HTTP 1.1. The referrer, spelled wrong, by the way, there should be 2 R's here, but the standard was written, and that's what it is the page you came from. The idea of this was to help you tell which advertising was working on your page or what the flow was through your page, but it turns out to be a security vulnerability. If you're viewing a page and then you go to another page, it tells that page where you came from, which might include private information. And for example, if you had stuff in the query string, it would be in the referrer. So it could, in principle, expose something secret about you and is a concern. Let's see some questions here. Let's see, in terms of HTTP version, there's now HTTP2, there is, and HTTP3 is on the way. Why are we still using 1.2? Well, nobody commands it. This is a very good question, by the way. Not, on the web, people put up servers, and they're often running really old protocols, and there's no enforcement mechanism to make people update. So old stuff lives forever. HTML version 2 will live forever. HTTP version 1 will live forever. I mean, what happens, this is why web browsers are incredibly huge. Web browsers have to support all these old protocols. If they stopped supporting old protocols, there would be pages you could not go to. And customers don't like that experience. The only people that ever had the guts to do that was iPhone. Steve Jobs hated Flash. And about 10 years ago, Flash was hugely popular on the web, a way to make beautiful graphics. But Steve Jobs said, I am not going to let Flash be supported on the iPhone. So he boldly sold millions of phones that could not see Flash websites, and he killed Flash. Everybody quit making Flash websites because this popular device couldn't see them, and so you'd lose the customers. But unless you have the power of Steve Jobs, of Apple, if you made a product that couldn't see all the web, everybody would just not buy your product. That's why there are other cases like China Google tried to make China stop doing bad things by pulling out of China. And they discovered what I think anybody could have told you, that if you think you're going to shove China around, forget it. You are not going to shove China around. Not the US military, not Google, not Amazon. Nobody's going to tell China what to do. So, however, Apple has been able to successfully shove people around. But businesses, not China. Anyway, so that's why old versions last forever. You say, why don't people just move to the new version? Because there's no way to make them move. All the people that have put up something 20 years ago that's still there, they don't even exist anymore. You can't make them move. So all the old stuff just tends to live forever. Yeah?
What is new in HTTP 2?
Yeah, HTTP 2 is the one that's, what HTTP 2 does is it has less back and forth messages, so it's technically faster. But it is far more complicated. And HTTP 3, I think, is more of the same, although I have only a vague clue about it. Yeah?
HTTP 2, HTTPS.
No, that's completely separate. HTTPS determines whether it's encrypted, and that would apply to all these. So you could have HTTPS and any version. It's a good question. That's a separate issue. The HTTP version that you see here is referring to the structure of the back and forth messages and what's required in these fields and such. So people say 400 is client-side error, that's right. Or 400 is an error of some sort. What's the difference between post and put? Post lets you send data to the server, and put also sends data to the server. And now that you mention it, I don't really know what the difference is. Put is used by web apps quite a bit on phones, phone apps. But now that you mention it, I don't really know the difference between post and put. It's a good question. We'll probably have a chance later in the course to look at them and see if we can spot a difference. There's not much of a difference. They both do essentially the same thing. What's the difference between using Google and DuckDuckGo? The difference is Google tracks everything you do and records it and uses it to target ads. When you go to a Google page, a large portion of search results are ads. So if I go here to Google and I search for dogs, a ton of this is ads. Here's ads. I don't know where you're going to find it, but I'm sure a lot of this stuff is in fact ads. And a lot of these are in fact ads, and it even has targeted ads. It has kept track of who I am with cookies, and it will put in ads to things relevant to me. So it's recording everything you do, like Facebook does, and targeting ads. And if you go to DuckDuckGo, they claim that they are not doing that. I don't know if you can verify they aren't doing that, but the point of DuckDuckGo is it's an alternative search engine for privacy advocates. DuckGo.com. A lot of people use this instead, and that's the idea. Supposedly, it does not track you and tell people what you're doing and target ads based on it. Whereas anything you do through a Google service is vigorously recording everything you do and transferring it to all the sites in the Google network, which is practically everybody, so they can target ads. So if you use DuckDuckGo, then your search history is probably not as widely distributed. Although I would imagine when they get court orders, they have to comply, although I don't really know. But at least they claim to be more secure, or more private is what they are. These are good questions. Post and put is a convention? I would think so. I heard some more information about post and put. Blocked by Brave. I don't know what that's about. You can do the same things with post as put, but put is considered a good practice for updates. Put is used to update an existing resource. Yeah, that post is supposed to store the data on the server. Yes. The most common use of post is to submit a form to server for processing. Yeah. Well, post and put both send data to the server. The difference is pretty small, but various people have a description in the chat there of the details. Good, glad to hear it. All right, so anyway, what else have we got here? The reason why the host is required is because you can run multiple websites on the same server. You can have one IP address listening on one port, and you can serve many different websites on the same server. And so it needs to know here, the host name tells it which website you want to see, in case many websites are sharing the same server. So the cookie is what you see, a cookie here with just a bunch of numbers, and it's a series of name equals value. Version equals 2, insights equals 35, and all this junk. GA equals this junk. This is typically what a cookie is. A name equals just a long random number. And the point of this is what adds that statefulness to HTTP. Original HTTP did not have any state capacity, and so Netscape added the magic cookie, that's what they called it. So they would have the server listen for these cookies that would come in with a request, and then it would save those in a database on the server. So now it could remember who you are. You'd send up a cookie, it would remember, oh, this person just logged in, they have a cookie. So when I send another request, every time another request goes to the same server, it automatically sends all the cookies again with every request. So now the server can look and see if it's seen that cookie before, and it might mean something to the server. Typically what it means is they know who you are, so it can change the contents of the page to target ads, or it can know that you've currently logged in, and therefore you should see some private resource like your email. And so now you have the strange way HTTP works, which is going to be at the heart of a lot of the attacks we do here. The way authentication works on the web is you send up your name and password with something like a post request. Then the server decides you're okay, and it sends you a cookie to mark your browser. And every further request your browser makes, it automatically includes the cookie, which re-authenticates at the server, so it knows who you are. So the proof of who you are bounces to your browser and back to the server and back to the browser and back to the server. And in principle, it can be stolen or copied by people in the middle and by you on your browser and proxy. This is a strange process, but that's how it works. That's what these cookies are doing. They are identifying you as somehow different from all the other people who might be viewing that page. And modern pages are heavily customized, like Amazon, where every person sees a totally different page. And the way that works is it uses all these cookies to identify you. However, Google is very, very sneaky because they really want to track you. And even if you delete all the cookies, Google also checks your IP address and information about your browser version, details, and all kinds of other information to stop anybody from hiding from Google. Which is why, if you want to do things like use DuckDuckGo and stop Google tracking you, it really won't do you much good. Because even though DuckDuckGo might not sell any data to Google, when you find a page and click on the page, the odds are above 90% that whatever page you go to will have a Google tracking cookie, and Google will find you again. So if you actually want to surf the web without being tracked, it's essentially impossible to do. One thing you could do is install a fresh operating system like Linux on a laptop, never log into anything, and start surfing the web on that without ever logging into email or anything, and then it would not be tied to your previous identity, but it would quickly develop a new identity, just from its IP address and such. And as soon as you log into anything, then they know who you are again. They tie it all together. So, I say the privacy on the web is pretty much an illusion. Yeah.
What if you exploit the API on the browser, the navigator?
Yeah, what about it?
If you change the values there.
Oh, yes. If you change, you could, in principle, change some values in your navigator to create more anonymity, and there are some people that do that. And there's things like evidence erasure that try to clear things. There are products that try to remove the marks. There's even something called GZapper that tries to specifically remove all the Google tracking stuff out of your machine. And I doubt it works. It might have worked at one time, but what happens is the geniuses at Google, as soon as there's a product like that, they immediately develop 10 new trackers. And they used flash cookies for a while. There are other kinds of cookies. They make all their money from tracking you. However, Apple has made it again so that iPhones are very hard to track. They've begun blocking a lot of this tracking stuff, and they have materially lowered Google and Facebook's revenues by doing that. So the part of iPhone's product brand is that they protect your privacy, and they've been doing it enough that they've actually been hurting that ad tracking model of Google. In retrospect, Vint Cerf, who helped develop the protocols that made the web, the ones we're discussing, said in retrospect, this was probably not a good idea. Now everybody's being spied on all the time to pay for all the websites. He said it probably would have been better if we developed a micropayment system where you could pay like 1/10 of a cent for every email or something, instead of having to have you be tracked all the time. And that's what some of the cryptocurrency people said. There was a cryptocurrency just for this purpose called IOTA. I thought it was a good idea. I actually bought some of it at one time, but it turned out to be all mathematically messed up. But the idea was you could make tiny little payments and pay for things with this without needing a lot of processing time. And you could switch to a different model where you pay for things instead of being spied on all the time. But anyway, none of that has succeeded, and right now everything is paid for by spying on you, just like all the TV services are paid for with ads. Although there's Netflix, which has subscription, and now subscription plus ads. So those are the two models. You get people to pay, or you invade their privacy. Those are the two known ways of paying for a service. Anyway, so the response that comes from the server has these headers up here that tells you, the main thing you notice is the status code, which tells you whether your response worked. 200 means you sent a good response and the server understood it and is giving you what you asked. Other things tell you that something has gone wrong. And here it tells you what kind of data it's sending you, what language it's in. This is JavaScript data. Here it gives you a date, server version, and information about how it's going to be transferred. And down here comes the data. And you see, all right, this data is sort of structured as name value pairs and such. Looks like JSON or something like that. All right, And by the way, the OK here is ignored by the browser. 200 is the code, and 200 always means OK, and they put that there just for humans to read it. All right, so there's another HTTP response, the banner of the software. By the way, it tells you what version of the server is running, and there's no reason for this to be accurate. In fact, it is considered a good security decision to lie on your banner. Instead of letting people know exactly which browser you're using, Apache Coyote 1.1, that might be a version with a known vulnerability, it's considered best to just change that, like Google Server or something. Change it to something generic, because telling people what version you're using of software is a security flaw. But by default, it will just give it the version. All right, and you can send a set cookie response, which will now store that cookie in the browser of the user. So this is how cookies are set. The server sends a set cookie, which is name equals value, and then some parameters like an expiration date and other things like a certain path. That's how the cookies are made, and your browser stores all these in a database. So every time you go to a website, it looks to see, should I attach some cookies to this request, and adds them to future requests until the cookie expires or until you clear your cookies, which you can do manually, although almost nobody ever does. So there's Pragma. You can put a Pragma line, which will tell the browser not to store the response in its cache. Otherwise, when you go to a page, your browser will not bother to load all the components of the page. If you've been there before and it's already loaded some of the components like images, it will have a cached copy of those images and just load it from your browser's cache to make it faster. This was more important in earlier days when the internet connections were much slower. But you can tell the browser that you do not want it to cache the contents of this page with this Pragma header. And the browser may or may not honor that, but in general, I think they do honor it. This also means, by the way, if you take the forensics class, we talk about this. If you look at the data stored on a hard drive, you will find fragments of all the web pages people have been viewing. So you can see what they're doing to some extent from the cached contents. They don't have timestamps in them, though, so it's not enormously useful. All right, and then you have an expiration date, and you can set the expiration date to a time in the past to tell it to always reload the content, and that's why this is set to 2009. That means it will always freshly load this page, it will never cache it. I want it to really load the page from the server instead of loading up some old version of the page. Then after the header is a blank line, then is the message body, and that will include the data, which will be of the type specified up here in the content type. So this is JavaScript data in a UTF-8 character set, which is one that lets you encode non-English characters with a certain encoding, which we'll talk more about later. All right, so get retrieves resources. You can send parameters in the query string. You can bookmark the URL, and as I say, the URL appears on the screen. It's saved in bookmarks. It's saved in query logs. So you should not put sensitive information in the query string, like a password. Post performs actions. You can put parameters in the query string and in the body of the message. Parameters in the body are not saved in bookmarks or server logs, so that's the correct place to put things like passwords. So a post will perform an action, like buying a book or logging in. So if you click the browser's back button and it tries to repeat loading a page with post, it will warn you, if I repeat this page, I will perform the action again. So that might be buying another book. So your browser will not reload a post page without warning you. A get page, it'll reload because that'll just get a fresh copy from the server, and that's harmless. All right, so head returns only the header, not the body. It is only used to test your server. Your browser, I do not think, would ever send a head request, although I have seen some phone apps send a lot of head requests, and I don't really know why. Options shows the allowed methods, which are these verbs, and put uploads data to the server to be stored on the server. And usually it's disabled, although some APIs allow it. APIs are listening processes which take signals which are in the format of HTTP typically, but they are not actually web browsers viewing pages. They are code sending requests to the server, typically from a phone app, where it sends a request, give me the picture of this person so I can show it in their profile, give me their phone number so I can add it to a contacts list. Little specific requests for data, which are not just going in a browser, they're going into an app that will use them to perform the activities of your phone app. The URL has this structure, and you should know it. It's very important. First comes the protocol, which is usually HTTP or HTTPS, although there are a lot of other protocols like Telnet and Mail2. Then you have : that separates the protocol from the rest of this. Then you have the host name, and you can put a port number here. If you don't put a port number, it has a default port for every protocol. So HTTP is by default on port 80, and HTTPS is on 443. And the other protocols have default ports, but you can run any service on any port if you want to. People to view it will have to include the port number specifically here. And then you have a path and a file name on your server if you want to refer to a specific file. And then you have parameters here after the question mark. That's the query string with parameter equal value. Yeah,
Why do we put a question mark in front of the parameter?
what is what?
Why do we put a question mark in front of?
The question mark is what you put there. So that's what, if you look at that Google search, that's part of the protocol. So let's bring Google and search for dog again. All right, and you can see up here. Now this one here doesn't show you the HTTPS. The padlock here means it starts with HTTPS, but this particular browser is hiding that from you. Then, there it is, when I click it. So here's the protocol, : here's the name of the server, here's the folder name, and then the question mark is what means it's done specifying which document on the server, and everything after the question mark is parameters, just data to be attached. So this is the protocol, and you should know all these parts. It's going to be important to us. Yeah, all right. And so there is, unfortunately, you can write a server that will choose to interpret this differently. The original HTTP, this would be a literal file on the server. You would have a folder where your web page lives, and if you make a subfolder, the folder name would be in there. That's the way my web page is. My web page is real old-fashioned. So when you look at this page, it's samsclass.info, this is the name of a folder, and this is the name of a file, 193s23.shtml. This is a literal folder name on the server and a file name in there. But you can choose to use this thing called REST, Representational State Transfer, where you send, now the old-fashioned way, you do it this way. You'd have the name of a server, then the name of a file or a folder, and then query here, the way Google has it. But you can choose to put the parameters in the URL as if they were folder names. I don't know why people do this, but it is pretty popular. They call this REST. So you put parameters here instead of that, and your server will just interpret these folder names as parameters. And this is another reason why the web is so insecure, because there is not standard ways of sending data. There's many different ways to send data. So you might, for example, say, I want to control the value of the parameters, but you won't know that this is a parameter. So you won't know to apply to it your security rules for parameters. So this is another problem of the web. There's quite a few problems with the web. One of them is that a lot of old versions of things are out there. And another one is there's a lot of competing ways of doing the same thing, so you can't interpret data with something like a web application firewall that tries to filter out attacks, has difficulty determining what fields mean, and therefore what values to permit. All right, so let's try a Kahoot. And good, I see why if Google can do that, can also work for people who use the famous dark web. I see a question from Lord Wayne, but I don't really understand it. However, Google, anybody you communicate with on the internet can put cookies on your machine and they can track what you're doing, unless you block them with something like an antivirus product that blocks known malicious websites. The dark web is interesting. The dark web is, if you search in Google, you will only see the public web, which are public web pages. Now anything, for example, you will not see other people's email if you search Google. It's not that it's illegal, it's that you have to pass through a login barrier to get there because it's not public information. And there's a ton more non-public information than public information. So that's one part of it. There's another dark web, which is behind the Tor browser. The Tor browser is using the Onion protocol, which is designed by the US military. And the purpose of it is for our spies in foreign countries to be able to send data home. So what they did was they made a system of servers that would encrypt data and forward it through random servers, so they could not find the physical location of somebody. So if you are a spy in Russia trying to send information back to the US government, you want to send data and you don't want anybody to know it came from Russia. You send it through Tor and it will bounce off many servers, and so you won't be able to tell where it came from. But then they said, if we use this special system and nobody uses it but spies, then they'll know you're a spy if you use it. So we'll make it public so all the people in the world can just transfer illegal content like pornography and stolen movies and stuff through it, and those innocent people will be the background our spies can hide in. And that's Tor. And Tor is, you download a special browser, and now all your internet traffic is randomly shouted to a lot of people. So in principle, if you download an illegal copy of a pirated MP3 through Tor, you might imagine that you're going to get away with it because it's harder for them to track you. Now, in fact, it's not all that hard for them to track you. But anyway, it does conceal your physical location. And that's another thing people call the dark web. Another use of that is if you want to put up a website and you want to do something really, really illegal, like distribute malware or sell drugs or child porn, you don't want to get caught, you put your server behind Tor. And now people can download Tor and connect to your server, but nobody can find the physical location of your server to arrest you. And that's where all the really bad stuff is. And those are called dark websites. And so anyway, that's the thing people mention.
Who goes to track you to the Tor?
Who can track you through Tor?
Can Google track you?
Can Google track you through Tor? I don't know if Google can, but the NSA absolutely can, because most of the Tor relays are in fact run by the US military. So you're actually handing your data to the US government in most cases, and that is increasingly true these days because there was a time, maybe a decade ago, when a lot of people felt like Tor was a privacy thing for like political activists, and a lot of volunteers like MIT, and I ran a Tor exit node for a while. Various people would volunteer and run Tor servers. I ran one for about 3 days. Then you get flooded with DMCA takedown notices. And then people analyzed the traffic, and they said, you know, if you run Tor, 99% of the traffic there is the most horrible stuff on earth, like child pornography and ransom notes and stuff. And there might be a few people trying to protest their government in there, but are you really improving the world? Mostly you're facilitating an incredible amount of crime for a small amount of good stuff. So pretty much everybody pulled out, and all the servers are now under control of the US military pretty much, and they can reverse engineer it to some extent. So there are also, I think, other nations' military have done it sometimes. I think there's a belief that other nations like China have developed attacks where they actually perform a denial of service attack on the Tor nodes to restrict the number of options to ones they can control. So for a brief period of time, they can track you on there. So it is a lot of private information passing on there, and it is possible to intercept and de-anonymize it, but it's very expensive. So it does mean, like DuckDuckGo, that for a normal user, if you use it, probably very few people will still track you. Unless you're doing something really horrible, it will become expensive to track you. Anyway, these are very good questions. The dark web is an interesting issue. And you can go there and find all sorts of crazy stuff if you're willing to be at high risk of dealing with criminals and dealing with malware and stuff. It's a useful thing to know how to get to the dark web and use it. And in fact, there's now a security service. If you subscribe to threat intelligence feeds, they will go to the dark web and search to see if somebody has hacked your company and they're dumping your data there and things like that. So just like you would just like police have undercover agents in organized crime syndicates to see what they're doing, threat intelligence agencies go to dark web to see what they're doing. And there's a guy that appears on the Pulse Security podcast with me every week, and he does this. And they asked him one time, they said, do you have like how many fake identities do you have on the internet? And he said, what, you mean today? Because he has all these fake identities and fake languages. And Brian Krebs is a journalist, and he covers Russian cybercrime. And Russian cybercrime syndicates have gotten so angry about Americans infiltrating them that they now have tests for you to get in where you have to name the characters from Russian soap operas from the 80s and stuff like that, as well as speaking fluent native Russian. You have to prove that you're really Russian to get in, and he self-taught himself Russian enough to get in there. And he's friends with all these malware people. He flies to Russia and meets them and stuff. He knows everything about the Russian organized crime on the internet. And that's his journalistic beat, and he's the world leader in it. Anyway, let's see what we got for a Kahoot here. 3A, there we are. And there. Let's see. Yeah, I see another remark in chat that's interesting. He said, the real test of the usefulness of an anonymization network seems to be whether or not a Chinese citizen can use it. I've been to China, and if you want to punch through the Great Firewall of China, you have to use special protocols. It's a different problem. I tried setting up VPN servers. There are special protocols just to punch through the Great Firewall. There's one I learned about from the people there. There are different kinds of VPNs designed to defeat the Great Firewall. But the Great Firewall is very smart, and it rapidly adapts to anything you do. Very, very hard to get unfiltered internet in China. They are not messing around. And I would, yeah.
I suffer with that. I cannot get into the Google.
Right, you can't get to Google or Facebook unless you get a VPN, and it's real hard to do, even if you try. They are very smart. I set up, I set them up, and they would block them within a few seconds. There are special protocols that work for a while until they block them. And also, it's presumably illegal, so what's that? There was one I used, a shadow thing. It was not exactly a VPN. It was one that was popular when I was there a couple of years ago, but it's probably blocked by now. You know, it's like everything. It only works for a while until they block it. Yeah, very hard to get unfiltered internet in China. So we Americans traveling there, it was very hard. You couldn't reach Google, you couldn't reach Twitter, and it was, you're sort of really isolated. Yeah, unless you actually can use the Chinese social networks, then you're pretty much out of luck as an American in China. Anyway, all right, let's try this thing. Okay, what portion is often get? Yeah, that's the verb, also called the method. The first thing is the verb, which is usually get or put. All right, so what method requires user confirmation when you click back? All right, that's post, because repeating a post would typically have another action on the server. All right. All right, what parameters are stored in bookmarks? That's the query string, is what's stored in your bookmarks. Cookies are not stored in the bookmarks. They're stored in a separate area in your browser. All right, and which one of these is RESTful? Okay, this is the RESTful one. These are all ones that are used. This is why I say it's very hard to filter internet traffic. These are all ways to send the same data to the server. This is one way to send it in the query string, ID equals 112, type equals student. This is XML, where you'd have ID and /ID, and student type and /type here, and put it in there. This is JSON, JavaScript object notation. You put it in these curly braces with this name value pair, and this is the RESTful way to send the same data. So if you wanted to make some kind of filtering engine that would look for, say, certain illegal values in the student field, you'd have trouble finding the student field to do that. But anyway, this is the one that's called RESTful, where everything appears to be a folder name. All right. So that's Karen, good. And Alexandra. And Zaza, I think Zaza might be a name from last semester. I might know who that is. but, Zaza's telling me who it is down here. Good, so I make sure I get the right name. Good, all right. So, that's good. And I see, all right, it's about time to take a break. I just see a question here which is worth mentioning. Why does TikTok doesn't allow you to have your data private? As you know, there's a huge press in America now to ban TikTok. And TikTok is a very interesting issue of privacy and also geopolitics. So TikTok, I tried using it once for half an hour and I thought it was boring. There was no COBOL and I left, but I'm apparently not the target demographic. People tell me teenagers will spend hours every day on TikTok and love it. So the thing about TikTok is it is very effective at zeroing in on what you like with their AI. So they know what you like, they know what they don't like until they're playing you very interesting little videos. And that's all it does, but it's incredibly popular in America. Now, a lot of people are upset in America because they see all their kids doing it, and this, by the way, goes all the way back to ancient Rome. Grown-ups always say, kids these days are doing stupid, crazy things and it's going to destroy the world. It's always been this way. If it isn't video games, it's pornography, or there's always been something kids are doing that they shouldn't be doing. But anyway, now it's TikTok, and they say, I spend all our days playing this game, and is it harming them? And all the data is going to China, and TikTok, a lot of people said they now know everything about our children, and they might target ads or use some other means. And so TikTok said, no, the data is not going to China. And then it came out that the data was going to China, and they had, in fact, illegally spied on the data in China. So that was a black eye for them. They lied about it and got caught. And some people say they're going to use TikTok to change the political values of our students by putting propaganda in TikTok, which certainly they could do. There's no evidence that they have done that. But anyway, there's another interesting issue, which I've heard in news reports, is that the TikTok that's in China doesn't do any of this. It's like Sesame, it's like NPR. It's just clean educational information without the addictive nature. And so they seem to know that this is bad for you, and they're letting us have the bad stuff. But of course, now another way to say it is they're giving us what we allow here, what our market wants. And over there, they're giving them sort of sanitized PG version because that's appropriate for the market there. So it's, you know, they say if you don't want your kids seeing all this filth, why do you make it legal? You know, that's another. Anyway, so it's a huge fight now about whether TikTok is harmful and whether it should be banned. A lot of people want to ban it, and so I don't think there's any simple answer. Anyway, let me stop the recording. And I see some more questions about ads and stuff. Let me see if I can deal with them.